This is Joy Varghese from Uncovering Chemistry. This is video number 24, chapter 10, Haloalkanes, Haloarenes, exercise question of your Ncert textbook. Here in this today we are going to discuss about 10.6 question, 10.7, 10.8, 10.9 and 10.10. Total 5 questions are there from your exercise. This you have to write it in your fair book for your ready reference and also for reading during exams. Okay. We will start with the explanation of these questions. See, now this is 10.6 question. Write the isomers of the compound having formula C4H9Br. Right? So writing the isomers for this, I think you know this is C4H9Br. You can see it's an alkane. Right now, alkane, this one, butane, what we say, 4 carbon. So either you can write there are 4 isomers possible. You can write carbon in a straight chain with the halogen. You can write carbon like this in a straight chain and second position halogen, that is what is given here. You can see here means 1 bromobutane, 2 bromobutane. This one is, sorry, you can see 1 bromo, 2 methyl butane. One you can write like this. This one, what I explained here, halogen you can keep at the second position. So 1 bromobutane, 2 bromobutane, 1 bromo, 2 methyl propane. What is given here, you can see 1, 2, 3, second position methyl, and 2 bromo, this one, 1, 2, 3 like this, 2 bromo. Then what is given here, 2 methyl. See, you can see 2 bromo, this is 2 bromo, this is 2 methyl, propane for 3 carbon. So these are the 4 isomers possible for this, right? Now next question what we are going to discuss is question number 10.7. Write the equation for the preparation of iodobutane from 1 butanol, that is alcohol, then 1 chlorobutane, that is alkyl halides, and but1-ene, that is a double bond compound, C double bond C, this is CX and this is COH, like this group what we are talking about. Now this we have already studied, preparation from alcohol, right? So preparation of alcohol in your textbook you must have seen on, see, this is the one, page number 294 it is given. This is this ROH in presence of red phosphorus, you will get what? RX, right? So this is the one what I am talking about. That page number, which page number? Page 294, preparation from alcohol, right? So remember this part. Now this is what is there, what you will see, OH group will be substituted by what? Which group? Iodine group. Iodine is a leaving group, what we say, sorry, attacking group, and here this is the leaving group in this case. Okay. Now the second one what we have discussed. What is the second one? 1 chlorobutane means what? RX is there and plus sodium iodide. Now where we have discussed this? See. Now in your textbook the second one is given at 295 page, Haloalkane and Haloarene. What is written? RX plus NaI gives you what? Ri plus NX in presence of dry acetone Finkelstein reaction. Okay. So this is the second reaction, Finkelstein, sodium iodide as dry acetone. Right? What you will get? You will get iodine will be substituted instead of chlorine. Finkelstein reaction 295 page number. Okay. So go through this. Now this, the last one, this is, you can, I think everyone know, HBr and peroxide means what? Anti-Markovnikov rule means the H plus and B minus. So the negative part will get added to such carbon which contain more number of hydrogen. This is anti-Markovnikov rule. Understood this part? So from that you will get what? What you will see? H will be substituted here. This H will be substituted on this carbon. This double bond will break. So here now this H, you will see here it is now H2. And here with this CH2 you will see bromine is substituted on this carbon. Can you see? So now again afterwards same what we have seen here, Finkelstein reaction, right? Sodium iodide, what will get removed? NaBr, NaBr will get removed, right? Now and iodine will get substituted here. So I think this 10.7 is also clear to you, right? Now 10.8, this we have already discussed in the beginning of nucleophilic substitution reaction. Embedden nucleophile means the nucleophile which can attack through two different sites are called embedden nucleophile. For example, cyanide is an embedden nucleophile because it can attack through C or N because of the following resonance structure. Means if it attacks to this carbon, and it can also attack through this. That's why they are called which nucleophile? Embedden. Okay. So this we have already discussed. Then you can see the next one is this one. Which compound in each of the following pair will react SN2 reaction with OH? So simple, what we discussed, always remember the order what we are seeing. Now here in this case Br is there and I. Both are alkyl halides only. So you can see CHI reacts faster than Ca3Br in SN2 because with OH minus. The reason is what? I is the better leaving group than Br minus ion. So who will react faster? This one will react faster. Now in this case CCl and this Cl. Now in this case this one is your tertiary halide and this one is your simple alkyl halide, right? So Ca3Cl is more reactive than what? Tertiary halide because of the steric hindrance in case. Steric means these are the electron donating groups. Now if you want you can write down this one. Now if you see in this case, this is the formula what was given. So these are the three electron donating groups which create which hindrance? The steric hindrance, right? Now here only one Ca3 group is there, right? So this one will react faster than this. Okay, so I think this part also is clear. Who will react faster? The 10.9 over, you can write it down in your book. Now 10.10, predict all alkenes that would be formed by dehydrohalogenation of the following halides with sodium ethoxide in ethanol and identify the major alkenes, right? You can see here 1 bromo, 1 methyl, cyclohexane. So this is, here you can see this is number 1 carbon and this is number 2 carbon, right? So what is written here? 1 bromo, 1 methyl. So this both position you can see Br group is there. Now what you can see, an alcoholic, this reaction minus HBr. Now HBr when we say no, so from this this carbon is your alpha carbon, right? From alpha carbon what is removed? Br is removed, okay? And from beta carbon what is removed? Hydrogen is removed. We remember dehydrohalogenation elimination reaction. So same thing happens here also. So what will happen? From Br is removed from here and H is removed from this carbon. So between these two carbon you will see a double bond is formed and Ca3. So 1 methyl cyclohexane is the compound what you will get after dehydrohalogenation. Clear? So either you can remove it from here or you can remove it carbon from this hydrogen you can remove. So then here double bond will be formed. But you can see from this carbon, alpha carbon, Br is removed and from this beta carbon you can see hydrogen. So between alpha and beta, so this is your alpha and this is beta, what you will see a double bond is formed between these two carbon. Understood? Now second one, what is 2-chloro 2-methyl butane. See now 2-chloro 2-methyl butane. You can see, I can number it here 1, 2, 3 and 4. So this is 2-chloro 2-methyl and 4 carbons means butane. This is 2-chloro 2-methyl and butane, right? So same alcoholic KOH or like this what you can see. So this one is simple dehydrohalogenation, right? So you can see this one is your alpha carbon. So if I remove from alpha carbon halogen, I can remove either hydrogen from here, from this beta carbon I can remove hydrogen, or from this one I can remove hydrogen, or from this one. So there are two products what we get. So if I remove hydrogen from this carbon, I remove hydrogen from this carbon, then this is your alpha beta, and here you can see this is alpha carbon and beta. Beta what is removed? Hydrogen. So this is the one product what you get, that is what 2-methyl but 1-ene. Less stable, being less substituted, minor product it will be. Now in this case, now suppose the second part what we say, from here beta hydrogen is removed, you will see there will be only HC. right? And from this carbon is halogen is removed. So what is the product? 2-methyl but 2-ene. More stable, being more substituted, what you can see, and it is a major product. Okay, right? So this is the thing what we have discussed about the second one. Now when we talk about the third and the last part, what is written? 2-bromo 2,3 trimethyl pentane. So this is the one what is given here. Has two different beta hydrogen. So this is one beta hydrogen and this is another beta hydrogen on this carbon, and hence gives two different alkanes 1 and 2. But according to which rule? Saidzev rule. Alexander Saidzev, what was written? It is pronounced as Saidzev. More highly substituted alkene means more number of, more highly substituted alkene means what? More number of alkyl group. Which group? Alkyl group near or with double bond carbon, right, is major product. Is which product? Major product. So here you can see, here in this case you will see here, from here this is beta, this one is your alpha in the beginning for this first product. Here I will remove Br from this alpha carbon, and from this beta carbon we will remove hydrogen. So between these two, you can see here these two, what is formed? Alpha, and this is beta, double bond is formed, right? Now next to the double bond carbon you can see what is written? 2-ethyl. 2-ethyl means this is your ethyl group, right? 3,3 means this is 3,3. This is dimethyl. This is also methyl and this is also methyl. This one, right? So 2-ethyl, 3,3 dimethyl. So total 3, what we say? Total 3, how many alkyl groups are there? And it is less stable and it is a minor product. Now why it is less stable? You will come to know by the second product, what we say. See, now in this case from here you can see what is removed? Hydrogen is removed from here. First it was removed for the first product from here. Now second product it is removed from here, and from this alpha carbon this Br will be removed. So you can see here CH2 is there, here it will be CH. This is your beta carbon and this is your alpha. Between two double bond is formed. Now you see the group. See, alkyl group how many? 1, 2, 3, then 4. So total 4 alkyl groups are there. Alkyl group in this product. In this there are 2 alkyl groups. How many? 2 alkyl groups, right? So here 3 are there. Ethyl, methyl, methyl, 3 alkyl group. So how many? Who is having more alkyl groups? So this one is having more alkyl groups. So you can say that this product is a which product? Major. Which rule it is? Saidzev rule. Okay, so I think this part is clear. 10.10 also everyone understood. Okay, write it down in your book and be careful with this rule what I was talking about, right? Now the next one what we say here. Now if you see this one also, this before what we discussed, it's also a Saidzev rule only. See why this is major product? Because see you can see here 2-methyl but 2-ene. So 1, 2, this is third and this is fourth carbon. In this case you can see this one is your carbon number 1, this is 2, this is 3 and this is 4. Okay, see now in this case when we say here 1 group, 2 group and 3 alkyl groups are there next to the 3 alkyl groups are there next to the double bond carbon. Now in this case you will see only 1 and this is the 2 alkyl groups are there. How many alkyl groups? 2 alkyl group, right? In this case total 3 alkyl groups are there, right? So that's why this is a major product and this is a minor product. Okay, so we'll be stopping our video here because this video is becoming more lengthy. So in the next video we'll be discussing about exercise question 10.11. This one, that is a conversion, most important part you have to remember. So this we'll be discussing in the next video. Okay, thank you.